So let's go through the exercise method of moments for a binomial random variable. Now I know that the screen looks even more hectic than the last video, but that's because my REPL is still not working, and we're going to need these functions here, or these formulae here, to figure out the problem that we're facing. So I said I'd keep these on the screen while putting up the code here, just to show that it functions. So what we're going to try and figure out here is we're going to go backwards, so to speak. We're going to create a load of binomial random variables, and then try and figure out the things that we inputted them into. It's more of a test just to see, does this method of moments idea work. So first things first, let's make a binomial expression. We're going to make two different variables here that we're going to use as storage, so A and B. A will be the number of trials and B will be the number of successful trials. And then we're going to use a while loop, so while A is less than K. Let's say if np.randomUniform, so a random number between 0 and 1, is less than P, then we're going to add 1 to A and to B. So the number of trials is going to have gone up by 1 and the number of successes. Otherwise, just the number of trials will have gone up, not the number of successes. And then, when we've done all the trials that we needed to do, if A is absolutely equal to K, we will return the number of successes, B. So hopefully that's relatively straightforward if we've gotten to this stage. So we have our p-val and k-val here, so 0.2 and 8. And then for and then we've got a good couple of different arrays here. I'm just going to expand this out here just for a couple of seconds just to show that these are all what the values of these are. So the sum and sum2 are both going to be variables, so they're going to have one value. And the indices p estimator and k estimator are all arrays with 200 different zeros in them. So for now this is all gone a bit all over the shop. Let's try that again. I'll put this up this way. Nah, it didn't work out very well now, did it? Perfect. We're back in business. Sorry about that. So the easiest one here, I think, is the indices. So we're just going to assign an x value to each one because we're plotting this. For indices indices I is going to be equal to I plus 1. So that's one of them over and done with, out of the way. Now let's try and work out what our sums are going to be. So their sums are just going to be for this mean and for the mu squared, or mu2, which is going to be the sum of x squared. So sum 1 is going to be equal to sum plus, we'll put in a binomial random variable. So, and we'll use our p-val and k-val here, but we'll just put k-val first there because that's going to actually be k. And then sum 2 is going to be equal to the binomial, or the sum of the binomial random variables squared. So we're going to put in binomial k-val p-val, and then we're going to square it. A common mistake that I see I make an awful lot myself is I end up putting this in for squaring because that's just normally how it looks like, but it's just multiply. So that works out in the end, hopefully. So the next thing, before I go on to doing our p estimator and k estimator, if we look at the functions for these, the parameters, we see that the mean and the mu2 keep coming up when we're filling these out. So what I do, if I was you, is actually make a little function for them, because there's a lot of typing otherwise. So we can see here the average is going to be 1 over n, which is the number of times that the number of indices that we've actually gone through, multiplied by the sum of all the terms. So that's actually going to just be our sum, and then for the mu2 it's going to be the sum of the square ones. So our average is going to be equal to so this sum 1 divided by our n, which is going to just be indices I. You can just say I plus 1 there as well if you want. They're the same difference. And then we're going to go average square and do the exact same thing, where it's just sum 2 divided by indices I. I don't mind all the x's here now, it's just because of the definitions. Now let's go and figure out our p estimator. So we literally just fill it in using the function estimator. I is going to be equal to 1 plus our average minus our average square divided by average. Then for the k estimator, we need to do the p estimator first because the k estimator, or because the p estimator is actually in the k estimator function. It's going to be equal to the average divided by p underscore estimator I. Don't forget about that I there because it'll go absolutely hectic if you don't put in the I. No, I'm a little bit concerned that I'm still seeing these x's. Let's just see what they're. Undefined name np. That's actually very handy. Let's import the libraries. That was one thing I forgot to do. And then we're going to import the matplotlib.pyplot, I think is the name of it, as PLT. Hopefully that works. So if we pull this out and we go to plots here, we should see that, yeah, even though they go all over the place at stages, they do hover around the two lines there. So hopefully that helps you out now. And if you want any more videos done, just please email me or let me know and I'll happily help.